Hello friends, today's question. A long cylindrical vessel is half filled with a liquid. When the vessel is rotated about its own vertical axis, the liquid rises up near the wall. If the radius of the vessel is 5 cm and its rotational speed is 2 rotations per second, then the difference in the heights between the center and the side in centimeter will be. So this is, you can say, a combination of or balance of forces. So in the initial condition, it is given that we have a container which is having some kind of liquid, and when it is rotated about its axis, something like this. So let us suppose this is the axis, y and y prime, and let us call this as initial condition. And we have a so in this one it is rotating about the axis y prime with the angular velocity of omega, and the shape we can say is something like this of the liquid. And we can just draw this part upper one, and we say that a point that is x distance, and at this point mg will be acting in downward direction, and we are going to have a normal this way, and the angle between is theta. So we can divide n into two components. This one will be over n cos of theta, and we are going to have this as n sine of theta, and we are going to have a force that will be equal to m omega square x. So we can write the equation, and we say this is our final condition. So we can write the equation that our n cos theta will be equal to mg, n cos of theta will be equal to mg, and sine of theta will be equal to m omega square x. So if we divide these two equations, we are going to get n sine of theta divided by n cos of theta, and this will be equal to m omega square x divided by mg. N and n cancels out, m and m cancels out. So this gives us tangent of theta is equal to omega square x divided by g, and which is nothing but slope of the line, which can be also written as dy by dx is equal to omega square x g, and this can be further written as dy omega square g into dx, x dx. So we say that x varies from the center of the axis up till the radius, and the y varies from the lowest point, that is 0, and this is our height h. Okay, so this is our starting, that is 0, and this is height h. So this point will be h and this will be 0. So we can integrate it. On the left side we can write 0 to h dy, on the right side will be 0 to r omega square g and x dx. So this gives us h omega square g, and we are going to get this as x square by 2 and divided by, sorry, not divided by, but 0 to r. Substituting the limits, we get h is equal to omega square g multiplied by x raised to power 4 divided by 2. Sorry, x raised to power 2 divided by 2. Not x but r. So we can say h is equal to omega square g multiplied by r square by 2. Now it's correct. And we are given that the speed is 2 rotations per second. So from here we can find out omega will be equal to 2 pi f. F is given to us as 2, so omega becomes as 4 pi. So substituting rest of the values, because radius is given and the speed is also given, g we know, so we can find out our h. So we get h is equal to 4 pi whole square, r square is our 5 centimeter, 5 into 10 is from minus 2 whole square divided by g. Let us suppose we are taking it as 10. Okay, much more convenient, and this is our 2. So we get h will be equal to 0.2 meters, or this will be equal to 2 centimeters. Options that is correct is option number D. Okay. So we can say option D is correct. D is correct. Okay. So this question was, you can say, looks like a little bit complicated, but it's quite simple by considering the equilibrium, or we can say balance of the forces, and which helps in getting the solution quite easily. This can be also solved by using the, you can say, difference in the pressure. We can say this is our delta, the difference is, this height is delta h, and we can find out what will the pressure at this point, and because it is balanced by the surface tension, so with that can be also used, but that is a little bit lengthy. For the shorter form, this is much more convenient to get the answer. Thank you.